Okay, this is Kinetic Molecular Theory of Gases Video 2. Yes, it's Video 2. You've already seen 1, you've already seen 3, now you're seeing 2. 1 and 3, the information there are the most important, and that's why 1 and 3 were done first. Number 2 is significant, it's important, but not as important as 1 and 3, obviously. Well, if we look at the slide, it says this is an apparatus for studying molecular speed distribution. And you say to yourself, molecular speed distribution? What is he talking about? Well, as you know, the average kinetic energy is directly related to the Kelvin temperature. It's the average kinetic energy that is related to the Kelvin temperature. The average kinetic energy, well, that must mean that some molecules have higher speeds and some molecules have lower speeds and some molecules must have around that average speed. So, therefore, there must be a distribution of speeds for molecules. And there is. And this is the device that you use to measure that distribution. So we take our substance and we heat it up in the oven, and now it's a gas and it's coming out of the oven and it's going through this thingy right here, and it goes to this wheel which spins, and it goes through the slit when it comes around, and then it hits this detector thingy right there, which is also a wheel which turns at the same time, and we get a distribution that looks like this. Whew. Here are the fast molecules, here are the slow molecules, average molecules. See, we get most of the molecules are a certain distance away from this average. So we're going to take that distribution that you just saw on the wheel and we're going to put it into a graph form. Now this is nitrogen gas, and this is a distribution of speeds for nitrogen gas molecules at 3 different temperatures. We have it at 100 Kelvin, 300 Kelvin, and 700 Kelvin. This distribution at 100 Kelvin. We can see that most of the molecules have a speed that's right around here, maybe about 250 meters per second. And you can see that if we go out to the left and to the right, that most of the molecules still have around this speed. So most molecules still have this speed right here, but then the rest of the molecules have speeds which are a little bit less or a little bit greater. And we look over here, there are many molecules, right? A great number of molecules you can see that have low speeds, but not very many molecules that have very high speeds. So we increase the temperature and we see that the graph shifts to the right, or the curve shifts to the right. And now most of the molecules, which is a decreased number, as you can see, because the number has decreased from this quantity to this quantity, but most of the molecules have a speed that's right around there, and then the other molecules have speeds which are around that speed, whatever it is. Maybe it's about 400, let's just say 400. And most of the molecules have that speed at around 400, and then the molecules, some molecules are slower, and there's a large number that are slower, and there's a large number that are faster, and we see that the number of molecules that are slower begins to decrease, and the number of molecules that are now faster, you see that increase. See, so when this curve comes down here and starts to flatten out a little bit, you can see that that's more than over here when the curve started to slow down and kind of straighten out over there. You can see there's more molecules moving faster at the higher speeds. And at 700 Kelvin we see the same thing. Now we take that graph, and most of the molecules you can see have a higher speed right here. So the greatest number of molecules have this greatest speed right here. Maybe it's about 657, maybe about 600 meters per second. Where'd my arrow go? There it is. And so we see that now the greatest number of molecules have a speed at about 600 meters per second, and we can see that the distribution is even flatter. So there are more molecules that are speeds around it that are slower, and more molecules that are speeds around that 600 meters per second that are faster, and there are fewer molecules traveling in the slower speeds. And there now, see, this is up even higher than we had before, so there are even more molecules traveling at the greater speeds. 100 Kelvin, see, 300 Kelvin, see, 700 Kelvin. Alright, so this is the distribution of speeds for 3 different gases at the same temperature. Now remember, if they're different gases at the same temperature, that means they have the same average kinetic energy. But what the difference is, sorry about that. It's 7:45 in the morning, it's a little hard to talk. I've only had half a cup of coffee. But anyway, the difference is that this is at a molar mass of 70.9, this is a molar mass of 28, and this is at a molar mass of 4. So you've got chlorine, nitrogen, and helium, descending molar masses, all at different molar masses, and we see even though the temperature is the same and the average kinetic energy the same, the distribution is different. It kind of looks like this distribution here. It looks like temperature distribution, only instead really it's a molar mass distribution, and we can see that chlorine has the greatest molar mass, and so its molecules are going to be the slowest. And nitrogen has the second greatest molar mass, and its molecules are going to be moving faster. And we can see that helium has the lowest molar mass of the three, and it has the fastest molecules. So we see that the distribution is moving towards the right, which means the molecules are getting faster, and it is not dependent upon the temperature, it is dependent upon the molar mass. And so we see the distribution kind of looks like distribution right here, where this is the greatest number of molecules that have whatever that speed is. For chlorine, this is the greatest number of molecules for nitrogen that has that particular speed, and we see that speed is increased. And this is the greatest number of molecules for helium, and we can see it's a very similar distribution. As we go across, more and more molecules have less of the higher speeds, and more molecules have greater speeds. Okay, so that's it for this video. If you have any questions, you can ask me or Mr. Walsh, or you can take a look in your text, and that will give you some of the information that you would need also. And I hope you have a good day, and we'll see you tomorrow in class. Bye.